Welcome to springlib.
All right. So in first part of this problem, we have two iodide compounds. First one is 0.1 molar barium iodide, and another one is 0.25 molar Ki. So we have to say in which one we have higher concentration of iodide ions. All right. So to do that, first we have to know which one will produce what amount or what concentration of iodide ion. So for that we have to write down the ionization reaction for each compound here. So BaI2 will be ionized to give us barium 2 plus and I minus ion. And since we have two iodide here, to balance the equation we have to have 2 here. That means from this BaI2 or barium iodide we will have 2 iodide ion produced. Now if the concentration of barium iodide is 0.1 molar, that means the concentration of iodide that will be produced from here will be 2 times the concentration of barium iodide, which is 0.1, and it will give us 0.2 molar iodide ion. Now if we look at the Ki, so Ki or the potassium iodide will be dissociated to give us K plus and I minus. That means here from 1 Ki we will have 1 iodide ion. That means if the Ki concentration is 0.25 molar, then the iodide concentration will be also 0.25 molar. So here we can see that the iodide concentration which is produced from Ki is greater than the iodide concentration which is produced from BaI2. That means in the first one, 0.25 molar Ki will have higher concentration of iodide. Now in the second one, we have zero point 0.1 molar Ki. It is given as 100 ml 0.1 molar Ki, and we have 200 ml 0.04 molar zinc iodide. So here again we have to find out which one here has higher concentration of iodide. So just to make sure that this volume data here um, is not of any use here, because whatever the volume here is, we can find out the iodide concentration just from the concentration of the compound. And while comparing the iodide concentration, we can ignore this volume data, so we don't need to consider the volumes here. We just have to find out how these compounds will be dissociated, and from there we'll be able to predict the concentration of the iodide ions in each one. All right, so Ki will be dissociated as K plus and I minus. So that means from 0.1 molar Ki we will have 0.1 molar iodide. And in case of zinc iodide, it will be dissociated to give us Zn2 plus ion and 2 iodide ion. That means if the zinc iodide concentration is 0.040 molar, that means iodide ion concentration will be 2 times 0.040 molar, which will give us 0.08 molar. So here we can see that 0.08 is less than zero point 0.1. That means in this case, uh, zero point 0.1 molar Ki will have higher iodide concentration than 0.04 molar zinc iodide. And finally, in C, we have 3.2 molar Hi, and another one is 145 gram sodium iodide, which is dissolved in water to make 150 ml solution. So you have to find the concentration of sodium iodide in that one. So let's find out the sodium iodide concentration in another solution. So we are given the mass of sodium iodide as 145 gram. So as we know that number of moles, so if we have to find the concentration of sodium iodide, first you have to find the number of moles of sodium iodide, which you can find out by easily just putting the mass of sodium iodide over its molar mass, and the molar mass of sodium iodide is 149.9 gram per mole. So from here we can find the number of moles of sodium iodide here, which is 0.967 mole. Now we have to divide this number of moles by the volume of the solution, which is 150 milliliter. 150 milliliter, and we have to convert this to liter because the concentration formula contains the volume in liter. So 150 milliliter times 1 by 1000 liter will give us 0.150 liter. Okay, so to find the concentration of sodium iodide, we have to put the number of moles of sodium iodide over the volume of the solution. So the number of moles we have calculated as 0.967 mole over the volume we have given as 0.150 liter. So from here we can find out the concentration of sodium iodide, which is 6.45 mole per liter or molar. So this is the sodium iodide concentration. Now the concentration of Hi is 3.2 molar. So since from here we can easily see that 1 molar Hi will give us 1 molar iodide. That means from 3.2 molar Hi we will get 3.2 molar iodide. And here from 6.45 molar NaI, which is which will also give us 6.45 molar iodide. That means apparently we can see that 6.45 is a greater number than 3.2 m. That means here in this case, the sodium iodide will give us higher concentration of iodide than the HI.